Hello everyone. For my 5-day AI agent capstone project for Kaggle, I built the personal privacy and digital hygiene sentinel. So we all know how AI agents are powerful, but giving them LLM access to our local files is very dangerous. So this was the core reason why I built my project. So what I did was I built a local MCP server that exposes three highly constrained security tools. The first is a local secret scanner. The second is a password checker or a password manager. And the third is a browser extension auditor. The LLM orchestrates these tools, but it operates under strict safety guardrails. So let's see it in action. So as you guys can see, this is my Streamlit dashboard, and this is the current agent like state dashboard, and the agent state is currently idle. So suppose if I want to go through any file or any directory in my laptop, I can just run a test scanner in the sandbox test directory. So as you can see, I get two approvals. So as you can see, the agent has found and exposed AWS key in the .env file. Now notice how the agent immediately transitioned into a pending human in the loop state and froze the execution. I explicitly designed the system so that the agent cannot modify or delete files without human approval. I'll go ahead and click the approve remediation now. So now as you can see, uh, the agent transitions to a remediating and safely masks the exposed key, and then it goes back to the idle state. This proves that the agent is safe and controllable. Now, if I do the same thing, like over here for the first AWS key, you can see that is remediated, and the second one is still pending for approval. That's why the state is active. So when I click approval for this, also it gets remediated. So suppose I run the same scanner again, it's going to say scan complete, and it's not going to give me any other human in the loop interventions as I've already passed this before. So let's move on to the second stage. Let's check out the password leak checker. So suppose if I give a very generic password for one of my websites, like just QWERTY, something like this. And if I check the password, it gives me an alert and shows how many times this password has been leaked in the databases. If I give another generic one like 1, 2, 3, 4, 5, if I check this password as well, it gives how many times it has been breached. However, if I give something like complex log, something like this, which it's hard to guess. It's going to check the database and say that this password has not been found in any data breaches as of now. So a big challenge in digital hygiene is checking if our passwords are leaked without accidentally sending your plain text passwords to a random AI cloud server. So to solve this, my MCP tool uses the key anonymity. When I type a password here, the Python code hashes it locally using SHA1, and then it takes only the first 5 characters of the hash and sends it to another API called Have I Been Pwned. So this API returns thousands of hashes, and the tool checks for the full match locally on my machine. As we can see that this password has been exposed hundreds of times, like the generic password I've just shown. By utilizing k-anonymity, the AI orchestrates a perfect security audit with zero privacy leakage. Now let's test out my third tool, which is the browser extension. So when I press on enter, it gives me the list of all the browser extensions that are available on my Chrome right now. You can see I have an ad blocker active. I have another ad blocker active. There's a VPN, and there's also a volume control module. So this risks and flags uh, all the access the extension has in my current laptop. Like it has access to my web requests, it has access to all the URLs and all the tabs open on my Chrome, and similar for the other ad blocker and for my VPN as well. It gives you a list of what all is available, and as well as for my volume master. So this third tool audits my browser extensions. Hackers often buy popular Chrome extensions and update them to spy on the users. So when I run this tool, the agent automatically locates my local hidden Google Chrome profile and then reads the manifest JSON files and the local files and translates these files into something that the agent can understand. Then it correctly parses these localized names of the extensions and flags any dangerous permissions that these uh, extensions have, which means that they have the technical ability to intercept traffic on every website I visit. This demonstrates the agent's ability to navigate complex real world file structures. So, and this is my secure vault. The secure vault basically has the database of all the API keys I have passed, remediated, or I have denied the access of. And now, finally, a top tier agent now needs statefulness, and long term memory, so it does not annoy the user with duplicate alerts. So every time the agent finds a risk or I make a human in the loop decision, it logs it into this local security vault. Because of this vault, I can scan the same folder again and the agent cross-references its findings with the database. If it sees I've already dismissed a specific warning yesterday, it will ignore it and it will prevent alert fatigue. By combining the MCP, human in the loop guardrails, K anonymity, and SQLite background memory, this capstone proves that an autonomous AI agents can be built to enhance local security safely and effectively. Thank you.